Okay, so here we have a really fun problem. We have two tanks that are interconnected, so we can see here, and tank A has 80 grams of salt in 30 liters of water. So what I'm going to do is just write initially, we know the volume of this tank is 30 liters of water. We also know 80 grams of salt is in this tank. And just to note, X is going to represent the salt in the tank, A. So I'm going to write X of 0 initially at time 0. We will have 80 grams of salt. In tank B, again, Y is going to represent salt in tank B in grams. So we are also told volume initially is 20 liters of water. So Y also initially, we know 50 grams of salt. And also in this diagram, we're told a solution is flowing in tank A at 3 grams per liter, and it's going in at 6 liters per minute. We're told in tank B, a solution of 4 grams per liter is going in at a rate of 5 liters per minute. And then we're told, we are also told, since they're connected, the tanks are connected, so we are told that 8 liters per minute flows from tank A to tank B. So I'm going to look at this top one. I'm just going to put an arrow going. Stuff is flowing from tank A to tank B. And it is flowing at 8 liters per minute. Similarly, 2 liters is going from tank B to tank A, so 2 liters per minute. An additional 11 liters per minute is draining out of tank B. So we also are given that we see that stuff is coming out of the tank B, and it's coming out at 11 liters per minute. So now we have a cool diagram. We are asked to find or set up two differential equations, which clearly we have because we have two tanks, and we're looking at amount of salt in each tank, and we can look at the rate of the salt going in or out of both tanks, and that's what we're looking for. So the rate that the salt is going in or out of tank A is going to be represented by this differential equation. Rate salt going in or out of tank B is going to be represented by this differential equation. And now we look for the rate of salt going in tank A. We know that that is going in at 6 liters per minute. And the solution is going at 3 grams per liter. And what's nice about that is the liters cancel out, so we get our desired units there of grams per minute. And then we also have something coming in at 2 from tank B. We see that it's coming in 2 liters per minute, and we multiply that by the amount of salt in grams per the volume of the tank, which is liters, and that volume of the tank is going to be tank B, and it's going to be 20 liters plus we have to look at all the rates going in, and we have 8 liters plus 5 liters per minute minus 2 liters per minute minus another 11, and that's times time t. And again, just to state that this is going to be in liters, and what's nice about that is the liters cancel out, and we have grams per minute. And again, just to highlight, as I kind of said it quickly, this 8 plus 5 minus 2 minus 11 is just us summing in. We got stuff coming in at 8, coming in at 5, so that's where 8 plus 5 comes in, minus 2 liters going out, minus 11 liters going out. And then we can simplify that a little bit to 18 plus 2y over, and the nice thing about this bottom here is this all actually cancels out, so we don't have anything other than 20 on the bottom, which you could see you could actually simplify that as well, but we'll leave that for now. And that is the rate going in to tank A, or out. Rate in. Sorry, I'm looking at rate in. But now we want to look at the rate going out. So the rate going out is very nice because it's literally just one thing, and that's going out at 8 liters per minute multiplied by the salt in grams in tank A over the volume, which is going to just be 30, plus we know that stuff is going in at 6 liters plus 2 liters, and then going out at 8 liters, and that's time. And the nice thing again is this stuff cancels out, so really we're just left with 8x over 30, and that's great because we essentially have our first differential equation, dx dt, as being the rate in, which is 18 plus 2y over 20, which again we can simplify if we want, but I will just leave as is for now, minus 8x over 30. So that is the differential equation representing the rate the salt is going in or out of tank A. Now we look at tank B. So similar thing, nothing new, we're just looking at, we gotta look at the rate going in tank B, and we know, let me scroll up, we could see things are going at 5 liters per minute times the 4 grams per liter of the solution. The liters cancel out, we're in grams per minute, which we want, plus other stuff going in, which we can see at 8 liters per minute. Something is coming in, 8 liters per minute, and that's coming in from tank A, so we know that's the salt in tank A over the volume in tank A, which again is 30 plus 6 plus 2 minus 8, which we really didn't have to write because we know it canceled out on the previous step, but it doesn't hurt to write it, I guess. I'm actually going to erase this right out part so I have a little more space. write it down here. But simplifying the rate in stuff, we have 20, and again, that's in grams per minute, but I won't write that just yet, plus 8x over 30. And again, all this is in terms of grams per minute. Similarly, on this other side, this is also grams per minute. It's all the right units. And then we look at the rate out. The rate out, we see that the rate out is, we have 11 liters, plus we actually have the 2 liters per minute going as well. So we know that that's actually just going to be, well, I'll write it, 11 plus 2 liters over per minute times the salt from tank B, so Y of T in grams, over the volume, and the volume is, I'm just going to write 20 this time because we can see that when we're looking at this particular salt in tank B per the volume in liters, it's going to be the same expression, so we don't need to keep writing that anymore. And again, that's per liter. Liters cancel out. We are in the correct units. And, well, I guess I can write this as 13y over 20. That's grams per minute. And we are pretty much done with setting up these equations. We just need to write it out. dy dt, the rate that the salt is going in or out of tank B, is 20 plus 8x over 30 minus the rate out, 13y over 20 and again, that is in terms of grams per minute, which is our correct units. And yay, fun problem.